Hello everyone, welcome back to mahasarkar.co.in. In this article, we are going to learn about the capillary and capillary action and why that capillary action is takes place. So reason behind that and some important application. What is capillary? In very simple words, capillary. You have used it in a chemistry practicals. You have used it in a physics practical also. So what is capillary? You must have seen that. It is a thin glass tube and having very small internal radius. So thin glass tube having small bore or radius is called as what? Capillary. So what is capillary action? Capillary action. Now, if you dip that capillary into the liquid, if suppose this is a beaker containing liquid and now you have dipped a capillary. So liquid was here up to this level. But once you dip the capillary, you will find that either the height of liquid inside capillary is more than the height of beaker surface. So it is rises by certain height. For most of the liquid you will find the same, but if you dip that same capillary in the mercury, then you will find that it is get fall. So this rise or fall of liquid inside capillary, inside what? Capillary when dipped in liquid is called as what? Capillary. This rise or fall of liquid when inside capillary when dipped in what? Liquid is called capillary action or capillarity. It is also called capillarity. In our day by day routine, lots of examples are there like sap through the roots reaches to the topmost branch. Sap through the roots of plants or trees reaches to the leaf branch with the help of this capillary action. While cleaning any surface, suppose water is poured on that surface and you want to clean it easily, so you will take a foam and then you will just keep it on that sponge. When you keep that sponge on that, what will happen? The water gets soaked immediately. So that is again what? Capillary action. Another use that in a chemistry or biology practically, you need the filter paper. So filter paper absorbs the liquid due to which action? Due to capillary action. In a summer season, lots of sweat is released from our internal body to the surface of our body or on the skin. So in which form that or through which means that sweating is takes place, then I will say our body is also having small pores through which that sweating is takes place. So these are some applications. Then third one important application, that ink in the fountain pen, ink pen, you know that fountain pen works on what? The principle of what? Capillary action. Okay, so this is capillary and capillary action. We are going to find out the cause of capillary action. Before that, we have to go through the pressure difference of pressure inside, outside, inside and outside free surface of liquid. Inside and outside what? Free surface of liquid. Now, to study this, suppose we will study simultaneously and we are not going to spare more time on that. Suppose this is the capillary and now liquid forms this shape. So first is which shape? Concave shape. Okay. Now suppose concave shape is there. We have familiar that because of angle of contact, force of surface tension will be act along this direction. So say this is force of surface tension T. On this side also, on this wall also, this will be the force of surface tension. So I can say that this is the point through which the forces are directed outwards. If I found the resultant of this both, then according to parallelogram, this will be the, say if this is T1, this is T2, then this T will be the resultant of these forces. So since resultant of force due to surface tension lies outside free surface, since the resultant of force due to surface tension lies outside free surface, then the pressure outside free surface is greater than inside free surface. Okay, so for concave shape, if this is point A is outside and point B is inside the free surface, then pressure at point A is greater than pressure at point B. Okay, so in this manner you can apply the same logic for convex surface. For convex surface, you can simply say that if this is the convex surface, if suppose this is the capillary, then this is the convex surface, then tangential components of force can be like this. So if this is T1, this is T2, then resultant of this will be what? Inside the liquid. So resultant of force due to surface tension lies inside. So F lies inside the free surface. F lies what? Inside free surface. So if point A is in the air and if point B is in the liquid, therefore pressure at point A is less than pressure at point B. Okay. And finally, if the surface is plane, for plane surface, logic is very simple. For plane surface, if suppose this is the capillary, and such type of plane surface is there. So one force along this side, another along this side. So resultant force here is what? 0. So force above and force below are same. So corresponding pressure is also what? Same. So these three are very important terms that we are going to keep in mind always. When surface of the liquid is concave, then pressure above the free surface of liquid is greater than pressure below the free surface. If the surface is convex, the pressure below the free surface of liquid is greater than pressure above the free. Hence, liquid is pushing upward and becomes convex in the shape. For plane surface, both the pressures are what? Same. Now, we want to find out why capillary is get raised by certain height. Means here, as we know that liquid always flows from point of higher pressure to lower pressure. So if I want to justify this term here, so liquid from beaker is flowing into the capillary. Means what? Liquid pressure in the beaker is definitely more than the liquid pressure in the capillary, and that we are going to prove. So the cause of capillary or the region of capillary that we are going to find out. Cause of capillary action. So let's start this. To start this again, consider the same type of example. I'll just draw a little wide capillary. Say this is capillary and this is container. So if container is wide enough, then it will not form direct concave shape. So it will form shape like this. But capillary is very thin as compared to the container. It will form shape like that. Okay, so liquid is rises. Say already I have said that liquid is risen by height h. So liquid is filled here. Okay. So consider 4 points: point A, point B, point C, and point D. So C and D can be this side also. We are going to locate them properly. So point A. What is the position of point A? It is what? Inside capillary. It is what? Inside capillary, but outside free surface of liquid. outside free surface. Okay. Position of point B in the liquid. Position of capillary is what? It is also what? Inside capillary. As you can see, this is point B, this is point A, this is point C, and say somewhere there point D. Inside capillary, and it is again what? Inside the free surface. Inside free surface. Point C. What is the position of point C? It is what? Outside capillary and outside free surface. And finally, point D. What is point D? It is outside capillary but inside free surface of liquid. Okay. So let PA, PB, PC and PD be the corresponding pressures at points A, B, C, D respectively. Just we need to clarify the thing. Surface is concave, so this equation is obeyed. Okay. So here case 1, first equation. Here PA is greater than PB. Why? Because it was concave surface. Surface is what? Concave. Okay. Now C and D, if I compare, then what will happen? Case 2, PC is equals to PD. Which surface? C, plane surface. Both are similar, as surface is plane, above and below the plane surface pressure is always same. PC is equals to what? PD. Now see, point A is also lying in the air and point C is also lying in the air. Atmospheric pressure at all the points is always same. So PA is equal to PC. So PD, listen carefully, PA is greater than PB. PC is equals to what? PD. PA equal to what? PC. So see, PC means PD. So I can conclude finally here. So PA is PC, but PC is what? PD. So using this I can replace this PA. Therefore we can have PD greater than PB. See, it's very simple. Are you getting? PC equal to PD. But PA is also equal to PD. Means if I want to write here, then I can say PA equal to PD. Okay. So if I write this PA by PD, then I can get PD greater than PB. That is, pressure of liquid in a beaker or vessel is greater than pressure of liquid in capillary, is greater than pressure of liquid in capillary. Hence, liquid flows from beaker to capillary. Beaker to what? Capillary, till the pressure is get balanced on the both sides. I hope you understood this article. This is another important article. If you go through the basic things here, capillary action, some examples are written already. Concave shape, if it is there, pressure above the free surface is greater than pressure below the free surface. For convex shape, pressure of the liquid is more than pressure of the atmosphere. For plane surface, both the pressures are same. Using this analogy, one can find the cause of. So now instead of that, if suppose you had given the convex surface, then what will happen? Everything is same, only this equation is going to change, and because of that, you are going to prove that PB is greater than PD, and hence liquid from capillary flows towards the beak. You just try this, it is very simple. I hope you understood this again. Thanks for watching mahasarkar.co.in. Have a nice day.